Today's video is going to be about conditional and biconditional statements. So here's an example with a conditional statement. We start out with two statements. Statement P, I had the money. And statement Q, I would buy the painting. Now I can put these two statements together into one statement, a conditional sometimes called an if and then statement. And that is going to be, if I had the money, I would buy the painting. Conditional statements can be written if P then Q form or in if PQ form. For example, if our school was nice, I would go there more than once a week. The initial hypothesis P is true, then the conclusion Q must also be true. In any conditional statement represented by if P then Q or by if PQ, then P statement is called the antecedent and the Q statement is called the consequent. Arrow notation. The conditional statement if P then Q can be written using the arrow notation P then Q. The arrow notation is read as if P then Q or as P implies Q. To do a truth table for the implication for the conditional statement. So a first step, as always, is going to be to fill in the variables. So let's say that I prove as possibility true, a possibility true, a possibility false, a possibility false for my P variable. And then for my Q variable, we could have it being true, we could have it being false, we could have it being true, we could have it being false. Now, the idea of the implication is that whenever the first thing is true, wherever the hypothesis is true, then so too is going to be the conclusion. So, if I read over the first row, this is a scenario where the hypothesis P is true and the conclusion ends up to be true. So, the implication in this scenario is true. Now, for the second scenario, the hypothesis is still true, but the conclusion Q is false. So, the implication is not true. Then, in the third set of the scenario, in a sense, the conditional doesn't apply here. The assumption isn't true, so the condition isn't true to be even considered. These bottom rows are going to say they are vacuously true. We are giving them the truth values because, first of all, no reason to think that they're false.
For example, determine the truth value of each of the following. A. If 2 is an integer, then 2 is a rational number. Because of the consequence is true, this is a true statement. An equivalent form of the conditional P then Q is equal to P then Q is equivalent to P or
The
Q.
negation of the conditional. The negation of P then Q is approximate P then Q is equivalent to P and approximate Q. Write the negation of each conditional statement. For A, if they pay me the money, I will sign the contract. For B, if the lines are parallel, then they do not intersect. In each case, we write the conjunction of the antecedent and the negation of the consequent. For A, they paid me the money and I did not sign the contract. For B, the lines are parallel and they intersect.
A biconditional statement is defined to be true whenever both parts have the same truth value. The biconditional operator is denoted by a double-headed arrow. The biconditional PQ represents P if and only if Q, where P is a hypothesis and Q is a conclusion. For example, let P, Q, and R represent the following. P, she will go on vacation. Q, she cannot take the train. R, she cannot get a loan. So write the following symbolic statements in words. So the solution on A will be, she will go on vacation if and only if she can take the train. For B, she can get a loan if and only if she does not go on vacation. Determine the truth value of a biconditional statement. So for letter B, if x equals -6, the first equation is true and the second equation is false. Thus, this is a false statement.